the Kinesis 116 Kinematics lab. We're going to be going over station E today. So to start off, we're going to go over angular speed. Angular speed is the angular distance over the amount of time that you're going. So the equation for that is angular speed equals angular distance divided by change in time. Just make sure you know over all your Greek letters when you're going over this. Just it might be on a quiz or an exam, who knows. So we know that speed only has magnitude, therefore it is a scalar quantity. Okay, let's go over the example. So we have a wheel spinning at 50 revolutions in 1 minute. So actually, the units for speed is actually radians per second. So we're going to have to convert the revolutions to radians, and then we're going to have to convert the minutes to seconds. So in order to do this, we have 50 revolutions in 1 minute. And then 2 pi rad equals 1 revolution. Okay, these cancel out. Move over. We have 100 pi radians divided by 1 minute. Okay, so now we converted our revolutions to radians. Now we have to convert our minutes to seconds. So let's start a new equation with this problem. So now we have 1 minute over 60 seconds. Okay, these cancel out. Move over to multiply 100 times pi, which would equal, let's see, 5.24 radians per second. Just make sure once you multiply 100 times pi, you also divide it by 60 seconds. And then you'll have your total angular speed. For angular velocity, it's pretty much the same thing. However, you're also looking at direction. So remember, as I said in our previous stations, if it's clockwise, it's negative. If it's counterclockwise, then it's positive. All right. Angular acceleration. So angular acceleration is a change in angular velocity over the amount of time. For example, we have a disk spinning at an angular velocity at a rate of 40 radians per second over 5 seconds. So we know angular acceleration is actually radians divided by seconds squared. So we have 40 radians per second divided by 5 seconds equals